In this video tutorial, we're going to show different navigation functionalities. So we have a model loaded here with several different subgraphs, and we're going to show how to navigate from one model to another. So one of the things you can do is you can highlight or isolate a node. So if you hold down the control key and click on a node, it's going to highlight that node in that graph, and it's also going to show you other subgraphs where that node is present. Right, so if you have several copies of that node, for example, I'm going to here break the hydrogen node, control click, you're going to see all the copies and reactions where the node is present, as well as other subgraphs. Hydrogen is present in a lot of them, and that number shows the number of times that node shows in that graph. So here you can click to go to another graph. So I click on urea cycle. That node is highlighted on the urea cycle graph, and I can see the 6 copies I made on the other node, on the other subgraph. I'm sorry, of how many copies of that node I have. You can click on the background to go back to the whole graph. Right. One thing you can do if you want to sort of follow where reactions are going is you can click on that node, and then you can hold control and sort of navigate by clicking on other nodes, right? So you can sort of track if you're trying to see where different flux is going, what metabolite is leading to what. You hold control and you go clicking, and that's going to highlight. You can go, for example, to a very busy graph. This can be very useful. So let's say transport in mitochondria is a very heavy graph. There's a lot of nodes, right? It's very difficult to see. So one thing you can do, you can just say pause the simulation, and then we're going to select all the nodes, and then we're going to fix all of them so it's not rendering the graph, so we can navigate a little bit more easily. And here you can kind of see where the functionality can come in handy, right? Control click, you can sort of go, oh, okay, these nodes go over here, and this is all the ones where hydrogen is present. Oh, which one's this? I believe glutamine transport, right? These are all the transport reactions that are hydrogen dependent, right? And you can sort of visualize things. It's parse these the mess that is this huge model. Another thing you can do is you can highlight a node. So for example, you can pick a node, let's say urea and the cytosol, shortcut age. It's further down here. Highlight metabolite age. Is going to load this temporary graph, and this is going to show all the reactions where that node is present, right? So the reaction and the subgraph, and you can double click this node to go to that subgraph. So here we have that reaction. Urea is present, and we are in the purine catabolism metabolite. Click on the background, and you again see everything. Right? So if you look at a node and you say, oh, I wonder what other subgraph it's in, what reactions come in and out of it, and so on, this is a good way of doing that. So yeah, these are some of the functions. The last one that we'll highlight is just the search function. So a couple of different buttons over here. Double click the background, takes you back to that graph. You can either focus the metabolite. So here if you say, for example, urea, it highlights that node. If you hadn't done that and you click urea, you can see that node was selected, but it wasn't highlighted. And you can also search by regular expressions, right? So you say, for example, starting with Na, that's going to highlight all of these nodes that start with Na. So, and it also shows here other subgraphs. So for example, urea cycle has 6 metabolites that start with Na. Click over here, and now we're in the urea cycle graph, highlighting all the metabolites that start with Na. So these are some functionalities for searching nodes across subgraphs, navigating to different subgraphs, and so on. So this allows you to, even though you broke a large map into several subgraphs, you can follow where metabolites go, where they are converted into other metabolites, and so on.